Okay, so the next thing is let's write out to the external file directories. This is going to be on the SD card. Now, unfortunately, there's really not a way to go in and look at the data on the SD card because it's protecting it for this application. And unfortunately, the way that they had to implement this, because the SD card can get pulled out and put in another phone, it can't protect the, it can't remember the ID of the application, the actual user ID in the Unix file system. So it can't use normal Unix file system, the directory access. It can't use the normal directory access that Linux has. So there's not really a way to go in and take a look at the data, but we can read it back and see what happens with it. So let's start off with our write files. And what I want to do here is, let's say, get external files dirs null. This says give me the root of the file directory that I own, which is nullable because it's possible that there's not an external directory mounted. If it's not mounted, let's go ahead and do a throw runtime exception. Cannot access application dir on external storage. So then inside here, I can say, let me give a subdirectory here as well. And this is kind of unfortunate because they used to have, I used to be able to actually look at that on the file system, so I could actually demonstrate, look, hey, the files are there. But we're going to read them back in, so that should be fine. So we'll say file external dir. Oops. And let's call this external stuff. So that'll be our subdirectory. We're going to go here. Let's do a make dirs on him. And let's call it subdir 2 so that we're not getting that warning. The warning was because I'm redeclaring this, the variable, the same variable name. And let's do our val file 5, subdir 2, and sample5.txt. And then we'll do a file 5.write text. Something kind of like that. So that should write out some information to the external file. Let's do a read for him as well. Now the read is going to be very, very similar. So we're going to get that directory. We don't want to make the directory on the read. File 5 is going to be that guy. And then we can say file 5.read text. Something like that. And we don't really need this extra delay on the end there. Whoops. Somehow I messed up my curly braces there. So that should be good there. I think that's all we need there. So this should allow us to read in that 5th file as well. So let's try running him. We'll first of all write our files. Then we'll try reading them in. Badoom, 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 4, and 5. And there's our external file. So now we've successfully written to the external directory. And the advantage of using the external directory is there's usually more storage there. Internal storage tends to be a little bit more limited. So you're not going to want to write any big files out there. The external storage is going to have some more space to it. Let's take a look at dealing with files inside the application APK itself. Now, so far we've seen this res directory. There's different types of resources with different configurations attached to them. So we'll see like this MIP-map, for example, it has these IC launcher files underneath all the different MIP maps for different screen densities. This one has drawables, values, has the color strings and themes and so on. But every once in a while, you have a file that doesn't really have some explicitly defined format to it that you want to adhere to. You just want to have raw data in a file that you want to get. There's really two places you can put files like that. One is underneath res, and you create a directory called raw. And then this is going to be files that can change based on configuration, but it can be really any old file you want there. So I'm going to put into there a little Android 1. Let me grab his attribution. Put them up here. So now we have Android 1 inside there. He looks like that. And then I'm going to grab and put an Android 2 in a different location. So these are things underneath resources that can change based on device configuration. Whenever your device configuration changes, we take a look at what the resources are and pick the best fit. We can also create a source main assets directory. And assets are different from resources in that they do not vary based on configuration. And you can have any type of subdirectory structure on it you want. So these might be a good place to put HTML files if you're using HTML for your help screens or something like that. You can put them inside here with subdirectories. You can have images inside there with subdirectories. Let's create a subdirectory on him. We'll call images. And the directories can be anything you want to call them here. The top level has to be assets, though. And let me go ahead and copy him over in. And this guy looks like that. So a couple different icons for Android guys. And what we're going to want to do is read these files in and write them back out. So we're going to read them from the assets directory and from the res directory and write them out. And there's a couple different ways we can do that. So what I'm going to do is I want to write these out to an images directory on the external drive, but I don't want to have it be my private one. I want to actually put these in the images directory so that any application can get to them. You know, if there's a gallery application, it can read them. If there's another application that wants to read images, it can read them. So in order to do this, I need to use a MediaStore to do this. Now, the MediaStore API is the one that I was mentioning. It's kind of like a REST API. So let's start off with private suspend fun, input stream, copy. Actually, I'm just going to copy this one because this one's a little hairy. And then I'll just go through the details on what this is doing. So I'm starting off with this helper function that is going to copy an input stream to a MediaStore. Now I've set this up so that the input stream is a receiver on this, making this an extension function. And inside this function, this at the copy MediaStore level is going to be the actual input stream that we're dealing with. In order to work with the MediaStore, we need to talk to it kind of like we would talk to SQLite. If we were talking to SQLite directly, I should spell that out. So SQLite is SQLite. Sometimes people pronounce it that way. I prefer pronouncing it squeal because it's not only because it's funny, it's one syllable versus three. You know, even if you say SQL, it's still two syllables. But SQLite has an API that lets you query it and talk to it. It's kind of similar. And to do this, what we're going to do is we're going to start off with first of all, the main base URI that we want to talk to. And that's going to depend on which version of Android you're on. If you're on version Q or not, which is like, we're right at version Q right now. Then I want to get the content URI for volume external primary. Otherwise, I'm going to use external content URI, which is going to pick one of them. It's usually going to pick the primary external storage place, but you can't necessarily be sure. It really depends on how the device is configured. This one says explicitly, I'm going to go for the primary one. So using this, I'm going to get the content URI for external primary there. So this is going to give me my base URI that I talk to. Then I'm going to create this thing called a content values. And content values is what you use to insert into the database. It's a map of key value pairs. So you have the column names and the column values. And this is how you would insert something into SQLite directory directly. You create this content values guy, and you can plug it in. I'm sorry, that's not SQLite. That's the content provider API. SQLite itself, you just write normal SQL statements. So this guy here, we're going to create this map of values. So the display name is actually going to be the file name. The type is image ping. We're actually just write pings out. And then what we're going to do is try to insert it. So we use a content resolver. That's the guy who's going to go and find out which content provider can handle this URL. Each content provider, when you define them, is going to define which URLs they respond to, and that information goes in the Android manifest. So every application can submit as many content providers as they want with unique URL prefixes. And what ends up happening with the content resolver is he goes off and says which application's content provider is registered to handle this URI, and then he serves up the response for it. So we're going to pass in here images collection. So we're going to be inserting into that collection. That's similar to doing post in REST, where you're saying, I want to post to a resource, like in our example, the movies URI. And that means I'm going to insert something. So we're going to call insert to that resource API with these content values. So it's going to stick those in there. It's going to create an ID automatically for us. We're going to have to specify that. That will return the URI of this new piece of data. Once we've got that, I'm going to do a use on this input stream. So note that I'm just saying use by itself. That's the same as saying this.use, which this over here is the coroutine context. I'd actually have to say this at, this at copy to MediaStore to explicitly say the this that's being passed into the function. So the receiver of the function itself. Because I'm inside this with context, there's another this in the way. So I'd have to explicitly escape it. Now, fortunately, the only one of them that has a use is input stream. The coroutine context doesn't have a use. So I can just say use by itself, and it's unambiguous. So that takes the input stream in the use, so it'll automatically be closed. I can just print out the URI I was just doing for some debugging. I was having some interesting issues when I tried this example. And the problem was that the code that I had copied from the Android site, these are all video. And so when I did my write, I changed them all to images. When I did the read, I didn't change them to images. I left them at video. And so the thing wasn't matching up. And I was banging my head on the table until finally I noticed that the URI said videos in it. And I'm like, oh, I forgot to change that. So be careful with copy and paste. It can really get you in trouble. This example, by the way, is accessible off that same website where it shows you how to do this. There's a couple of little differences in how they do things a little bit later on when we talk about storage access framework. Their examples, for some reason, don't use the newer form of registering activity results. We're going to see that a little later. So I had to convert my example to use the register activity results and do that right. But we'll see that one a little bit later. This should insert that and give us a URI representing that one piece of data that we just inserted. Now what we want to do is actually write the data out to the file system, because all this did was put a database entry in to say what is actually what we're registering, so this file. So now we're going to use that input stream, and we're going to open an output stream based on that URI using the content resolver. So that's actually going to create the output stream to write the file out to the disk. Use that as output stream. And then I'm just going to say input stream copy to output stream. And if we take a look at that, that's a nice little Kotlin extension function that does the whole buffering thing that I showed you earlier on, where we have our little buffer and he buffers them out. We're using the default buffer size, so he's actually using 8K, which is much better. But this will copy the data from the input stream to the output stream. And then if there's an issue there, I'm going to say, oops, I can't find that output stream to write to. So that's what the copy to MediaStore is doing. That's the base function. And what I'm going to be doing is picking where that input stream comes from differently based on if it's in assets or if it's in raw. So to do the raw one, again, I'm doing this with dispatchers IO. I'm going to say resources open raw resource, passing in that resource ID. So it's r.raw.android1. Note that I don't put the PNG on there. That's just the Android one. So I'm going to take him, open him, and then use that input stream to copy to the MediaStore. Boom. And here's the file name that we're writing to. For copying assets, it's a little bit different, not a whole lot different. We're going to say assets, which is directly defined on the activity, .open, and I'm going to specify this path. So from the assets directory, it's images/android2.ping. So in this one, I have to specify that file extension. When you're doing your resources, you don't specify a file extension. When you're doing assets, you do specify it, and you specify the full path. So again, I'm going to use that input stream and say copy to MediaStore. Boom. So I was able to factor out that common functionality to do the actual write out there. So let's take this guy, and I'm going to create a couple buttons. So let's make another row here. And let's say store raw, let's say. This is going to be store asset. And these guys, I'm going to do more than just one thing inside here. So I'm just going to say copy raw to MediaStore. And then this one, I'm going to say copy asset to MediaStore. So I should just move those in there. I don't want to do one other thing inside here. I'm going to say dump image files, which is just going to give us a list of stuff that we've stored inside of our directory. So let's take a look at dumping out these image files. So we're going to add in a little helper function here to actually get a list of all the images in the database. So I'm going to get a little data class helper here too. So a little data class that has the URI, the name, and the size of a file, just so we can report that. And this function list image files is fairly similar to one that's actually at the data storage media provider there. So inside here, what we're going to do is once again do it with context dispatchers IO, because we're going to be doing this in a background thread that is going to be doing blocking IO. And I'm going to have a list of images that I'm going to return. So I'm going to query the database, fetch some information, put it on. So what you're going to see code-wise in here looks very similar to what you do if you were using a content provider to directly access SQLite. So again, what we're going to do is start off with our upper URL, whatever the base URL is for fetching our content. We're going to define a projection, which is going to be basically the select clause in your SQL statement. So these are the columns that we want to get out of the database. We're going to define a sort order, which is going to be display name ascending. And then I'm going to run content resolver query, passing in which table we want to go to. So that's basically the URL, the projection, what we want to get. We don't have any selection arguments, so we're just going to pass in nulls for the selection and the selection arguments, and then the sort order. That is going to return a cursor for us or null if it couldn't run it. So I'm going to say that !use. Cursor is auto closable, so we can use this .use there as well. And then we're going to fetch the data for it. So this stuff inside here is exactly what you'd see if you were working with SQLite directly. We're going to grab the columns just to hold on to them. So we're grabbing them by name rather than depending on position. If you're ever doing direct SQL and you're fetching things, don't use the indices of your projection down in this part of the code where you're fetching things, because if anything up here changes, you could be getting the wrong columns. So we're going to get which indices represent those columns. And then we're just going to run through that cursor. So while cursor move to next, grab the data out of that row, and then I'm going to figure out what is the URI, because this is just an ID. So it's basically a number representing that piece of data. We need to build it into a URI. So what we do is call content URIs with appended ID, passing in that base URI, and then the ID on the end of it. And so then down here, we're going to say, add an image info to the list with that content URI name and size. So we're just going to build our list up and just return that list at the end of this. So that's really all we're going to do for this list image files thing. That dump image files is just going to use him and join it all to a string. So I'm going to get that list of the images that we have, and then call join to string, separating them with new lines. And each of those lines is going to look like URI with a new line and then indent name colon size. So we'll see a URI and then the name and the size underneath it, just so you can kind of see what that data looks like. So that should happen anytime we insert the things into the database. So let's try running that. So there's our other row there. I'm going to say store raw, and boom, we see down here, content, blah, 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 Android 1, 1, ping. If I say store asset here, Android 2, 1, ping. Now what this is telling me is that I still had some data from one of my test runs, and it's trying to write out Android 1 a second time in that same directory. So what I'm going to do is I'm going to go delete that, then we can run this again. So let's come out of here, close him. I'm going to close this other one that I had running. And what I'm going to do is go to a file manager on this device. And I'm going to go to images from files. And underneath pictures, we'll see here's the images that I had put in there before. So I'm just going to select those all and delete them. So we're going to start clean here. And let's run this puppy again. So I'm going to say store raw, and now we get Android 1 ping, store asset, Android 2 ping. Now, based on the timing here, sometimes that information that we're fetching to retrieve here might not have been finalized in the content provider. So sometimes you'll see that 0 pop up like that. But it did have the rest of the information in there. It just didn't have the file hadn't finished writing out yet by the time we queried this. So if we take a look now over in the file manager here, and I went to files, images, underneath pictures, you'll see that those 2 images got stored. They're now available for this file manager to display them to us. Okay, so now the next thing we want to do is set up so that we can actually read those in. And what I want to do is set this up so I can actually display these guys on the screen. Let's add in a couple buttons. And I'll fill in these other details in a minute here. So this button 1 is going to say Android 1 ping. Button 2 is going to say Android 2 ping. And then let's deal with putting this image on the screen. So this is like a 2-part thing that we're going to do. I'm going to set up 2 mutable states, image URI and image bitmap. Image URI is going to be what we're going to use to look up the bitmap. And then once we have the bitmap, we're going to display an image on the screen. So let's define those guys. So we're going to have an image URI, which is going to be a nullable URI, and image bitmap, which is an image bitmap that's nullable. Image bitmap is a Jetpack Compose bitmap that can be presented inside an image. So if we come back down here, I'm going to set the image URI, just the URI, to looking up Android 1. So we're going to create a little query that goes against that media provider to tell us which URI has the display name Android 1.ping inside of it. So I could get a little bit more specific, including the full path and things like that, but this is just going to look for just the name by itself. So let's take a look for that find image. And I'll bring him in. So what this guy is going to do, he's going to take the name of the image that we want to find and return either a URI or null, depending if we find it or not. Once again, we're running this on the IO dispatcher so that we're running it in a background thread that can block. Look up our URI the same as before. I really should have just defined a common function for this because I do the same thing in 3 different spots at this point. Get my projection, which in this case, I just care about the ID and the display name. My selection criteria is going to be display name equals question mark. My arguments to plug in the question marks are just going to be that name. That's the only argument I have inside the selection. And then I'm going to run the query, passing in the collections. That's that URI, the base URI, the columns I want, the selection, the arguments plugged in. And then I don't care about sort order. I'm just going to be getting the one guy. I'm going to take that query and call use against it to get my cursor. And I really should have called that cursor instead of query. I think it's when I copied this from somebody else. Cursor. because I copied this from that Android site and tweaked it quite a bit to get this to work. So I want to rename that returned cursor. And then that guy can be cursor. So when it's not null, we're just going to call it cursor. We're going to find what that ID column is again. And then if we can move to next, notice I don't need a while here because I'm only expecting one element back. If I can get to that first row, I'm going to get the ID, and then just my answer is that appended URI. So I take the base URI and append the ID on the end of it. Otherwise, it's null. Now, this is where I had gone wrong, where instead of saying images here in all these spots, it had videos when I copied that piece of code. But now that they match, that should all work just nicely there. So the next thing we need to do is be able to actually fetch the data from the file system. And this is where things get a little tricky. Unfortunately, with the media provider that we're using for this guy, he acts a little differently between Android 9 and Android 10. For Android 10 and beyond, we're at 11 right now is the latest one. For Android 10 and beyond, you don't need to have any type of permission to use this API to get it. For Android 9 and before, you have to do the permission check for it. So I'm going to set up the code in here to do that permission check. And so what we're doing inside here with this check permission and open image, the idea is before we can open the image, we have to ask the user, is it okay for us to have permission? Now, we don't necessarily have to ask this for Android Q. So I could actually put a check inside here saying, if I'm Android Q or later, then skip doing this request permission. So I could inside here check to see, is it Android Q? In this case, I'm going to leave it having this up so you can see this dialog come up and see where it comes up. Normally, what you want to do with runtime permissions is try to make sure they come up as close to where the user is actually using that function as possible. So in this case, we're going to check it right before we open the image. And if we already have the permission read external storage, we're just going to open the image. Otherwise, we're going to request the permission. And we do that using this launcher that we defined over here. So this guy here, we register for activity result. What it's doing is it's going to actually forward an intent behind the scenes to another activity that the system's defined. And that system is going to handle the permission request. It's going to bring up a little dialogue, let the user know, hey, the application's asking for this permission and so on. And then once the user is done saying yes, no, or not, or yes or no, it's going to come back to us. Behind the scenes, there's a function inside the activity called onActivityResult. And what that does is it gets the result back at that point. So it's kind of our callback for returning to this function. That was a little messy having it be all separated. And they came up with this register for activity result setup, which sets everything up to do that for us. It's much, much easier to deal with because now everything is encapsulated in here. And you can have different permissions in different blocks rather than having to deal with them all in one big onActivity result. One of the things to look at in here, if we take a look at this contract that's being passed in, request permission, we'll see here that he has a create intent. So this is actually the intent that he's going to use to send off to the other activity. But he also has this parse result. And this is going to tell you what kind of information is coming back to you. And inside here, we've got the result code coming from the other activity saying it's successful or not, and the intent, which can have some data coming back from the other activity. And it's going to parse that information out for us and check to see, hey, did everything work okay? The main thing we're looking at here with this contract is we're getting a string coming in, which is a permission requesting, and a Boolean coming back, which is saying if it's granted or not. And we'll see here this result coming to synchronous result is the Boolean. This one is not very readable. There's other ones that are more readable, so you can actually see what's going on here. The problem is this whole check self-permission thing in here is making it a little more complex. But what's happening is it's returning a result of either false or true to, where is he? This lambda that's passed in here. So that's where that Boolean is going. The true or false comes into this lambda. So the contract drives what arguments are passed into the Lambda, so you'll know what actually is coming back. So inside there, I'm going to say if we're granted, then I'm going to start a coroutine to actually do the open image there, because I'm not currently in a coroutine. Otherwise, I'm just going to put up a little message saying you need read permission. And you're going to have to come up with a strategy for what to do when the user denies permissions. You could just disable functions, but if something's a core function of your application that you have to have that permission for, you're going to have to be a little bit more strict with the user and say, hey, you just told me that I can't do this. The application's kind of worthless without it. And then describe to them how they can go back to the settings for the device into the application page and explicitly set the permissions there. Let's say that I go to the application settings or the device settings, go to apps and notifications. And let's take a look at this files app that we're dealing with here. There's a, oh, he doesn't need any permissions. How about this one here? He doesn't need any permissions. Does anybody need permissions in here? Oh, my other one I had set up. So this guy here. I can go to permissions and it's going to tell you which permissions have been allowed or denied. And then the user can come here and change that either to deny ones that have been allowed or to explicitly add them. Recently, they also added this remove permissions if the app isn't used. So if the app isn't used for a few months, it'll actually come along and remove these permissions so that it can't possibly be doing anything in the background with them. Okay, so let's see. Now we need to define open image just to actually be able to read that image. What we're doing here is we have that image URI, which was one of those two mutable states that we set up there. And we're going to say if that's not null, then I want to use the content resolver to open up the input stream on it. So just like the way we wrote the open output stream before to write the data, we're going to use the open input stream to read it back in. So we'll do open the input stream, call use, and then I'm going to set image bitmap to use that stream, decode it into a bitmap, and then convert it into an image bitmap that Jetpack Compose needs. So you're going to use the factory to decode it to a bitmap and then convert it into an image bitmap. So once we have that, that's going to set that mutable state, which will drive the UI. So if we look at where these guys are used again, so down here, if the image URI changes, so and he's non-null, then this launched effect will be triggered again. And the launched effect is just start up a coroutine to do something. So in this case, as soon as he changes, we're going to go check the permissions. That will end up setting the bitmap. When the bitmap is set, it will display this image. So hopefully that will make all that work. Let's try running this. And I think what I want to do is add in a explicit button just to list the, let's say, dump images, just so we can double check that we have something. So we'll just do the dump images on that. Now, again, because this is just a single item inside this Lambda, and he has the same signature as the Lambda, I can convert that into onClick equals function reference. Just shorten things up a little bit there. So now if I run this, this will allow me to double check that I have those images all set up. Boom, there's the image information there. Now if I hit my Android 1.ping, hopefully you need read permission. So I requested, where was that? So I requested that permission for read external storage. Unfortunately, I didn't put that inside the manifest. So you need it in two places. Remember with permissions, originally they had it just in the manifest. And when you installed applications, it would present a laundry list of all the ones you wanted in the manifest, which, you know, the user would be like, I have no idea what these are being used for. Now with runtime permissions, you still have to put it in the manifest, but then you also put it in at runtime at the point it's actually being used, so the user can actually know. But it has to be in both spots. So in this case, I forgot to put it in the manifest. So I'm going to go into source, main, Android manifest. And I'm going to come up here and say uses permission and read external storage, just like that. I'm not going to have the stuff backed up. And let's try running that. Dump our images, that all looks good. Hit Android 1 ping. Now we're getting the permission check saying, is it okay? I'm going to say, yeah. And then boom, we get that showing up. So permission check was triggered because we set that URL, or the image load was set because we did the URL, and then this image down here in the bottom was put up there because the bitmap was read. If I hit this guy, boom, shows the other one as well. So now we've got it reading from that media provider.